ventricle. Okay, and then from there we go out through lateral or medial ventricles or down the central canal. And the pink is supposed to be choroid plexus. This is missing part of it right here, but that's all right.
And capillaries.
Huh? What?
We're talking about the pink stuff.
It's the choroid plexus.
Composed of ependymal cells and capillaries.
All right, okay. So we have three parts to the ear. We might want to come around this way if you want to see. I can't show it both ways. So this is the external ear, which has auricle or pinna, external auditory canal or meatus, eardrum, which is also called the tympanic membrane. So sound waves are funneled in here. Of course, there's hair and sinus glands. Then they play a little rhythm on the eardrum. Okay. And then we transfer to the auditory ossicles, okay? The first one, you can see here, where it's attached to the eardrum. Okay? That's the malleus or hammer. Next one in line is the incus or anvil. Third one is the stapes or stirrup. And notice the stapes has an oval foot on it, and that's going to fit in the oval window underneath here.
So what's this guy here? I mean, I know this is the hammer. Is this part of the hammer too?
Yes.
Okay.
This is the hammer.
Oh, I got you.
Okay. So we're going to conduct sound waves, but we're also going from a large surface down to a smaller surface, so we also amplify the sound. Now this is filled with air, this is filled with air. This also is open here via the eustachian tube, auditory tube, or pharyngotympanic tube to the middle ear, except normally it's collapsed. It only opens up when you like yawn or chew, and that equalizes the pressure on both sides of the tympanic membrane. But that opens to the middle ear. Air, 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 all over there. Now we come here. This part's carved out of bone. What part of the bone is it? That's a portion of the temporal bone. And so this is called the bony labyrinth. It's also lined with a membrane. Now this part's missing, by the way. Should have another half to this. Okay. So the oval window is here, and as the stapes moves up and down that creates pressure waves. The oval window is connected to this. This is what?
Scala vestibuli.
Vestibuli. Okay. Scala vestibuli. So that creates pressure waves, and eventually the pressure waves will extend down here and move the basal membrane up and down. That pushes the hair cells embedded here in the pectoral membrane. It bends them, and that's what you hear as sound. It's a mechanoreceptor. The rest of the waves come out through the scala tympani and push out on the round window. The round window is here. Now everything's actually all connected together. There's fluids in here, and they're all connected together. So besides having a bony labyrinth carved out of bone, we also have membranes inside, a membranous labyrinth. So this is the cochlea is for hearing. This is called the vestibular apparatus. This part here is called the vestibule, and that has two sacs in it connected together, the utricle and the saccule. And those are for static equilibrium. Like, where is my head? Is it tilted or not? Or am I moving in a straight line? Okay. And that has receptors called maculae. The maculae have these, again, little hair cells sticking up, and they're embedded in gelatinous material. And in the gelatinous material are little bits of calcium carbonate, basically chalk. So when you tilt your head, gravity pulls on that and bends the hair cells. And that tells you your head is tilted.
What's the purpose of the calcium?
I think it helps with the gravity thing. Okay. And then these are the semicircular canals, and they're at 90-degree angles, so they tell you which way you're moving. So this is dynamic equilibrium. And at the base, it's enlarged, called the ampullae. So different ones get stimulated depending on which way you're moving. And these have what we call the crista ampullaris. Again, little hair cells sticking up into something called the cupula. And fluids outside move, and that moves the cupula, which moves the hair cells. And that tells you which way you're moving. And this is all connected together. Okay.
Which one has to do with acceleration?
Both do. This is linear acceleration. This is dynamic.
Gotcha.
Okay. And of course, I mean, a lot of these are tonic receptors, not basic, except we are kind of used to some types of, like I'm not aware that I'm turning around on this earth or we're going around the sun. So some things we are used to.